part D here, we let h be the function defined by h of x is f of quantity x squared minus 1. We want to find the first three non-zero terms and the general term of the Taylor series for h about x equals 0, and then find the value of h of 1/2. Well, if f of x is 1 plus x plus 1 plus x plus 1 squared, etc., then h of x is f of x squared minus 1, and we're simply going to replace x with x squared minus 1. So we'd get 1 plus x squared minus 1 plus 1 to the first plus x squared minus 1 quantity plus 1 to the second, etc. x squared minus 1 plus 1 to the third, and so on. Simplifying that is going to give us 1 plus x squared minus 1 plus 1 is just x squared. X squared minus 1 plus 1 is going to give us x squared quantity squared, and the next term would be x squared quantity cubed, etc. Simplifying one more round, we get 1 plus x squared plus x to the fourth plus x to the sixth, etc. And we want the actually we only need the first three non-zero terms. Now it's very important, if they only ask for the first three, you have to do the first three. But they also ask for the general term here, and so that's going to be, we have x to the 0, x to the second, x to the fourth. Again, so if that's the 0, first, second term, we're going to have x to the 2n. And so that's all there would be for that. And we found the first three non-zero terms and the general term about x equals 0, and finally we want to find h of 1/2. Well, we can tell that this is again, whenever you're looking for the value of an infinite series, you only know that if it's geometric, and this is geometric. If we were to write here our a would be 1 and our r would be x squared. So you really have to be careful with that. If we went back to that general term and wrote it as x squared to the n, then that would be geometric. So our common ratio is x squared. So from this, if we're trying to find the value of h of 1/2, this converges to a over 1 minus r, which is 1 over 1 minus x squared when x squared is less than 1, or x is between 1 and 0, since x squared can't be negative. Now, since 1/2 is in that interval from 0 to 1, we can find h of 1/2 just by plugging 1/2 into 1 over 1 minus x squared. Let's just say h of x is, if h of x is 1 over 1 minus x squared, then h of 1/2 is going to be 1 over 1 minus 1/2 quantity squared, and that would be 1 over 1 minus a fourth, 1 over 3/4, or 4/3. And so we've met all the criteria for the problem. We have the first three non-zero terms, we have the general term, and we found the value for h of 1/2. That does it for this part and for this problem.